is asking us which answer is an example of the law of multiple proportions. So I want something to look at, something to do with the law of multiple proportions. And I think we have to pick between three choices here. So law of multiple proportions. And then what we have here is, so we have, so A is asking us two different samples of water are found to have the same ratio of hydrogen and oxygen. So let me write this down. So two samples of water are found to have the same ratio of, say, H and O instead of writing the full guys here. So H and O here. Hydrogen, oxygen. When, and then B is asking when hydrogen and oxygen react. So I'm going to say when H and O react, mass of water is formed. The mass of water formed is exactly equal to mass of H and O reacted. And finally for C, C is the mass ratio of oxygen and hydrogen and H in water is 8:1. So looking at these three statements, let's look at the first statement here. Asking us, so I want the law of multiple proportions. So from first of all, we have to define what the law of multiple proportion is in order for us to solve this question. So taken straight from the dictionary, I have here the law of multiple proportion states that if two elements form more than one compound between them, then the ratio of the masses of the second element, which combined with the fixed mass of the first element, will always be a ratio of a small whole number. So what does that mean? So let's use an example here. And if I have H2 plus O2, this can give me a lot of products, right? I could get H2O2, I could get water, I could get basically any I have any compounds that I could get with H2O2, right? So it's making definitely more than one compound here, and it's saying that it can always be expressed in a ratio of small whole numbers. So when we're talking about whole numbers, we're talking about basically we're relating the masses as a ratio to each other first. So so that's kind of what our what the law of multiple proportion is. And we're looking at number 1 here, or number 8 here. It says two samples of water are found to have the same ratio of H and O. Well, this one doesn't really talk to you about anything here, because what I have here is I have again two or more, or one or more compound between them, right? This is only talking about water here, and this, so water is simply only one compound, and it has a ratio, the same ratio of H2O. So in this case, it's a 2-to-1 ratio, right? For two hydrogens, I have two hydrogens per an oxygen, right? So I have two hydrogens per one oxygen. And in this case here, this is not a example of the law of multiple proportions, because we're not talking about the mass here of two different compounds here. So this here is, and it's not expressed in whole numbers. In this case, it's only just for one compound here. So this answer A here is not correct. So it's not an example. B here is asking when H and O react, the mass of water formed is exactly equal to the mass of H and O reacted. Well, this is just a straight formal definition of the law of conservation of mass, right? So if I had H2 plus O2 gives me H2O, well, I would have to balance this chemical equation, right? I would have to put, again, a 2 on this side and also a 2 on this side for me to make the masses equal, right? I have 4 hydrogens on this side, 4 hydrogens on this side, 2 oxygens on this side, and 2 oxygens on this side, right? So in this case, this is a law of conservation of mass and not the law multiple proportions here. So this answer is also not correct, right? Because this is simply just stating the law of conservation of mass. And then finally, which means C has to be our right answer, but why is it our right answer here? Well, it's saying the mass ratio of oxygen, hydrogen, and water is 8:1, right? So I'm looking at the ratio. So let me write water here. Water is H2O. And the masses of hydrogen and oxygen here, remember, I have 2 hydrogens here, and I have 1 oxygen, right? And this is going to equal, I have 2 times 1.008 grams per mole. And I also have 1 times, this is 16, I'll just assume 16 grams per mole here, which is going to equal, this is approximately equal to 2. This is equal to 16. So this here is again, if you look at the ratio here, this is a 2 to 16 ratio, or you could say 1 to 8 ratio, right? So oxygen to hydrogen would be 8:1. And in this case, I wrote hydrogen to oxygen, but it's interchangeable in this case here. So you can say here that this here is a 8:1 ratio, right? 8:1 ratio. So we proved that this existed, and we can also say that the mass ratio of oxygen to hydrogen in hydrogen peroxide. So hydrogen peroxide is a different compound, right? So now we have 2 compounds in play, which is what the law of multiple proportions says, right? I need 2 compounds in play here. So I want oxygen first, so I'm going to write 2 times O here, or 2O. And I have 2 H's. This is going to equal 2 times molar mass of oxygen here is 16 grams per mole. This guy here is also 1, I'll round it to 1 here for the sake of our calculations. This is going to equal, I have 2 times 16 is 32, 2 times 1 is 2, and this will equal, the ratio here is simply just 1 in 16, right? This is, or 16 and 1 here. And this here is my ratio, this here is my ratio, which means that these guys here are expressed in whole and small numbers, right? Or ratio of small numbers. And small, you can, obviously there's some limitations on what small is, but in this case here, I have 2 products. So I have 2 elements here, the same 2 elements, hydrogen and oxygen. I'm forming more than 1 compound, right? I have one of them is forming water, and one of them is forming hydrogen peroxide, and they both can be expressed in a ratio of small numbers, 8:1 and 16:1. So therefore, C here is the correct answer. And if I'm looking at the problem here, again, it's not the best formatting, but they said option C here is correct here. And it's asking us A here is not example, which is good. B here is not example as well. And C here, let's see. Again, the solution is kind of incomplete because some of these guys are cut off here. But they did say that C was the correct answer. So I'm going to say solution is correct. I'm going to say missing analysis here.